Okay, so we are back to Pythagorean theorem, but it's being presented here in a different form. The form is in the form of identity. Again, identity is an equation that works for all angles. And the trigonometric identity related to Pythagoras theorem is this, that sine square of an angle theta plus cosine square of the same angle theta is always equals to 1. It is a trigonometric identity in the sense that doesn't matter what the angle is, it works for all angles. So for example, sine of 18 degrees is squared plus cosine of 18 degrees is squared also equals to 1. This is always true for any angle. So sine square of 30 degrees plus cosine square of 30 degrees also equals to 1. So this is an identity, and this identity actually comes from the Pythagorean theorem, because if you pick this as your triangle where the hypotenuse is 1, and then you call the opposite to angle A, little a, opposite to angle B, little b, it means that for this particular triangle, remember, sine is going to end up being the same as the quantity A. Why? Because it's opposite sine of angle A, which is opposite over hypotenuse. The opposite is the value of A. The hypotenuse is 1, so meaning sine of A is A, right? Because the denominator 1 makes no difference there. So here you can say sine is A. The same thing can be obtained for B, which is cosine. So if from the Pythagoras theorem you have that a squared plus b squared equals to 1 squared from Pythagoras, and then if you replace a with sine and b squared with cosine squared, you get the trigonometric identity. So now in this box you have all trigonometric. So the first 6 trigonometric are the ones that are about reciprocals. That's established in the beginning of this section when we went over what sine, cosine, tangent, and then if you flip those fractions, you get the other trigonometric. So those are the same. So nothing new here. What is new is the quotient identities, because you see towards the end that the tangent can be written as sine over cosine, and because cotangent is the reciprocal, if you flip that, you have that cotangent is cosine over sine. The Pythagorean identity, this is the main one. And again, if you divide both sides by sine square or divide both sides by cosine square, you get this one and this one, which they are equivalent, but they are useful also in these other forms. The ones on the bottom are the pairs of cofunctions I mentioned above. They are described in terms of the angle. Okay, so please take a look at the applications here. In terms of applications for trigonometric triangle functions, we can use what's called angle of elevation and angle of depression. So in order to make this, and this is an example already solved here. So imagine that you are somewhere, let's say on the street, and then you look up, right? So here is the sight, horizontal line. If you look straight ahead of you without tilting or lowering your head, you have this horizontal line. Now, if you see something fly in the sky, let's say a plane. This is my plane, sorry, I cannot draw a very good plane. You have to raise your eyesight up. So when you do raise, you can think of this as forming a right triangle, where this angle here is called angle of elevation. So angle of elevation is always formed with the horizon, the horizontal line, and then if you raise your head, you have this top side of the triangle with the horizon, the flat bottom. That's what we call angle of elevation. Now, if you are on the top of the hill, and then instead of looking up, you're looking down, let's say there's a boat somewhere down there, and you're on the top of the hill, you have to look down. As you look down, you do have a right triangle, because this is right with the horizontal line. If you look straight ahead without tilting your head, this is the horizontal line. But if you look down, horizontal line with your eyesight down is what we call angle of depression. So some of these problems is going to have something in terms of angle of elevation, angle of depression. The best way to deal with them is by drawing a sketch of the situation, whatever the situation be described. And then you put the relevant information in that sketch, which is always going to involve a right triangle. And then you can use Pythagoras theorem, you can use Pythagorean identities, you can use the trigonometric functions definitions in order to compute whatever is needed.